So, we will continue with module 7 in this electronic systems packaging course, and this will be the last lecture in module 7. Now, if you recollect, we will take a quick recap. If you recollect, we have been looking at basically assembly details of components, and we have seen various types of components being used: plated through hole, SMD devices. Earlier in the lectures, we have seen flip chip. We have also seen BGA assembly, because BGA is with solder balls. The same thing has got to do with CSP components, and we have also seen mixed type of components in certain complex designs. And secondly, we have seen the various processes for soldering, and we have also seen the basics of soldering process in terms of materials that are being used for soldering process. And then we also have spent some time on the thermal profiling for reflow procedures, right, and we have also spent some time on alternatives to lead based soldering, that is the use of lead free soldering in systems packaging. So, we will continue with that. We will also look at lead free materials, and then we will in this particular lecture go into some aspects of green electronics and conclude with this module. And finally, at the end of this lecture, we will have a question answer session, a tutorial session, a set of questions that will be worked out here in this particular lecture, so that you can clear all your doubts that you had during this particular module. Now, at the outset, I want to mention that in this particular packaging course, we will have different sets of question papers that will be posted in the website, which can be tried as a home assignment, and it can be communicated to the instructor, or if you have any questions on this, it can be emailed to the instructor at your convenience. So, we will move with the technical aspects. Now, in the earlier lecture, we talked about low melting lead free alloys. Now, as you know, lead based alloys have been used for a long time. Of them, the eutectic composition tin lead 6337 with a melting point of 183 degrees centigrade is the most commonly used. Now, because of RoHS legislation, we are moving into lead free. Now, if you look at the alternatives of lead free, of lead based in using lead free alloys, the idea is to lower the melting point, but most compositions of lead free alloys are above 183 degrees centigrade, the normal eutectic temperature that we have been used to working for a long time. Now, the first alternative that we briefly discussed in the last lecture is indium based alloys. That is, if we use tin in combination with indium, you can lower the melting point to as much as 118 degrees centigrade, and it is useful for temperature sensitive components that are being used in that particular design, so that you can have minimal thermal shock on the components. Now, cost and availability is a problem. Cost, because indium is used, which is expensive, and then availability in terms of the manufacturers of this particular type of alloy. So, there is not enough global market for indium tin alloy as of now, but there are many players in the market who have been using indium tin for specialty applications. Now, the next alternative is using bismuth, where you use bismuth to the extent of 58% and the rest 42% is tin. Here the melting point is 38 degrees centigrade. A very convenient temperature profiling can be done for components that are susceptible to thermal shock. Cost is comparative to tin, and the problem here is it creates brittleness in the solder joint after reflow soldering process, and it also has a poor fatigue resistance. So, on the one hand you are looking at lowering the temperatures, but on the other hand you have problems with the solder joint reliability issues. So, therefore, when you convert from lead based soldering to lead free soldering, please have a look at the reliability issues once again. So, disadvantages in using let us say indium and bismuth could be reduction in wetting, maybe you will have to use a special flux material. Now, we will move into high melting point lead free alloys. In this specifically, we will look at tin, silver, copper based alternatives to tin lead soldering. Now, tin silver copper alloy has good wettability, fatigue resistance and good overall joint quality. Now, typically what we are looking at in every solder joint, we have seen that also that we want to reduce the intermetallic growth as much as possible. We have seen in the solder joint a cross section in the last lecture that there is a base metal rich area and a solder rich area in a solder joint, and depending upon the thickness of the growth of the intermetallic layer, you will have different alloy compositions of the intermetallic layer formed, and these intermetallic layer compositions are the defining factor in the solder joint quality. So, if you have brittleness, then it is due to the nature of the intermetallic growth and how it can withstand thermal stress strain during the lifetime of the product. Now, in tin silver copper, we have seen a ternary eutectic composition, that is tin 3.5% silver and 0.9% copper. This has got a melting point of 217 degrees centigrade. We have also seen about SAC 305 alloy and also SAC 405 alloy in the previous lecture. Now, the lead free solder can also come with antimony as one of the components. So, antimony based lead free solder is also available. Now, this one will stop the gray tin formation, that is intermetallic growth involving alpha tin and beta tin phases at low temperatures, but this is toxic and so this is a problem. So, this is not widely recommended. Now, the characteristics of lead free solders, as a summary I would like to project it here. If you look at this particular table, the entities here are the compositions of the lead free solder that are available in the market, the melting point range and some of the comments that are available from the literature. So, if you look at tin indium, which we have seen just now, the melting point is very low, 118. The strength of the solder joint is of a big question mark in terms of long term reliability and also the cost. Okay. Tin bismuth 138 degree centigrade is the melting point. It is an established material. The availability concern of bismuth is always a question. Now, again these are specialty applications. Okay. So, unless and until you require these kind of alloys, you have to look at cost. A solder joint that is established on a printed circuit board will add to reliability problems, and if you have so many joints, hundreds of joints on a printed circuit board, then you have to look at the solder joint quality, reliability and issue, and that is directly related to the choice of the lead free material. Now, some of the literature materials that have been well known or well studied by various groups, various organizations or industry has been listed here. Tin zinc has also been tried. The melting point is 199 and the problem is corrosion. Then you have compositions that are as complex as having tin, antimony, bismuth and copper. Okay. So, this is a complex system, and then you have the melting point at 218 degrees centigrade eutectic. It has got high strength, excellent thermal fatigue. Now, cost could be an issue, and we are worried about the continuous availability of such kind of mixture. Then you have tin, silver, zinc instead of copper. Then the range where it can be used is 218 to 221, high strength and good thermal fatigue. Then you have tin copper, tin to the extent of 99.3, copper 0.7%. Look at the melting point, well manageable in terms of your reflow zones that you can set in the equipment, 227, high strength, fairly high melting point. Therefore, here you should look at your components that are being used in this particular design or assembly, and that which can withstand these kind of temperatures, because if you say 227, then your peak reflow would be set to, let us say, 3 to 5 degrees centigrade above the melting point, and you have to look at the vulnerability of your component at these temperatures. Although the reflow residence time peak reflow zone is very short. Then you have tin, antimony, good shear strength and thermal fatigue, tin, silver, antimony. There is a Motorola patent, high strength. Then you have as complex combination like tin, copper, antimony and silver. All of these are added for special properties that can be exhibited by the solder joint. It could be wettability, it could be thermal fatigue, good thermal fatigue or resistance to corrosion and so on. So, here the problem is high melting point. Now, with the kind of substrates that we are using, organic substrates, and the kind of packages that we are using, we have to try to keep the melting point of lead free soldering to around 220 if you are using in mass production. So, some of these combinations may not really work out for high volume production. Then you have tin silver, 221 is the eutectic and high strength and high melting point. So, in summary, what you can look at is in the market there could be a wide variety of lead free solders. The most common is SAC 305 and SAC 405 alloy. You could try using that because of the well known characteristics of the solder joint. But again, if you are looking for special applications, low density board, okay, and it could be ceramic packages that you want to use or a combination of ceramic and plastic packages. And then if you know the handling of these components, then you can choose from a wide variety of materials. The only thing is, if it is a mass production, you have to look at continuous availability so that you can standardize your procedure. Commercially available lead free solders, just for interest, for people who are interested in knowing the kind of products that are available. Obviously, this is not an exhaustive and complete list. These are representative examples that have been taken from the literature. Solder name, for example, Indalloy, where this is a specialty alloy and it contains tin, indium and silver, and melting point, as you can see, it is very ideal, 187 degrees centigrade. There are problems like potential indium lead incompatibility, will require lead free plating on PCB lands and component leads. So, the preparation of your PCB surface has to be tuned if you are using this kind of a material. Then Alpha Metals produces alloy HTM, where it is tin, bismuth, copper, silver, 212 degree centigrade, and liquidus temperature is too high, and if you are using it for other applications like more other than reflow, if you want to use it for a wave soldering process, then there will be concerns. Then you have tin, zinc, indium, AT&T. The composition is 81% of tin, 9% zinc, and 10% indium. If you look at the melting point, very attractive in terms of working conditions. Again, the compatibility of the PCB has to be looked into. So, if you are migrating to lead free, your PCB surfaces is also recommended to be lead free surface finish. So, you could either have a tin finish or you could have a nickel gold finish. Then you have cast in from AIM products, which is basically tin, silver, copper, antimony, 215, liquidus temperature too high. But unless you do a kind of a trial and error method, and if you do a careful examination of the solder joint alloy after the product has been established and is in working condition for over a year, it is very difficult to precisely write the failure aspects of each of these materials. Tin, silver, copper from DOE US. So, the various percentages are mentioned here, again 217. So, these are the comments that are available from the literature, current literature. So, we will summarize with some of the opinions or comments that have been seen over a few research papers and experiences of various manufacturers who have migrated to lead free soldering. Now, in general, we can surmise that if you are using lead free solder materials, what are the situations or what are the conditions that you need to look at for a bare printed circuit board. Now, at the PCB side, you must consider benefits of reduced use of brominated flame retardants. Okay. Now, as you know, all these FR materials, FR4, FR3, FR5 and so on, the classifications that we have seen in the earlier classes contains bromine as one of the key components used to exhibit the property of fire retardancy or flame retardancy. Okay. But that is also being looked at carefully worldwide as a material that needs to be banned from the PCB industry or the electronics industry because of the RoHS regulation. So, if you are using lead free material for interconnect assembly, then you also have to logically look at removing bromine from your base substrate. Okay. So, reduced use of FR materials which contain bromine as one of the components is a key issue. Now, there are other alternatives. You could use phosphorus based substrates. Japan is one of the countries which have taken a lead in reducing bromine based organic substrates. They have moved to phosphorus based substrates, organic, and they have been found to be as reliable as glass epoxy bromine based substrates. So, currently the cost could be prohibiting, but eventually we have to look at alternatives. Avoid use of low grade laminates, because as you know, if you work with lead free, you are going to work with higher temperatures. So, choose laminates or substrates that have high TG, so that it is compatible with the various processes. It could be reflow process, it could be wave soldering process. Now, as I repeated in the previous slide, change to pure tin as an etch resist. So, your process sequence should be including tin as an etch resist. The top and bottom layers of your multi-layer printed circuit board could either be finished with tin, or you can use some kind of a thermally stable solder mask. Okay. So, you can avoid a metal etch resist completely, use SMOBC, that is solder mask over bare copper. SMOBC stands for solder mask over bare copper. So, many companies move into this kind of a finish. So, instead of having tin or tin lead as a finish, the only requirement is that your copper should be well treated, okay, to avoid corrosion during its life or the product life, and you can have a very good solder mask that is highly stable at the temperatures of operation of the PCB, and which can take care of the heat that is generated from the surface of the PCB during the operation of the product. So, these are some considerations that you can have when you parallelly move into lead free solder materials. It is not enough that you just look at lead free soldering, you have to look into totality, a holistic view of the entire system, including most importantly your printed circuit board. Alternative finishes could be, as I said, firstly nickel gold is a very good option. You could go for lead free hot air leveling, right. Most of you are aware of tin lead hot air leveling, hot air solder leveling. Now, since you have to avoid lead, you can look at tin hot air solder leveling. Then you can look at palladium, silver and tin alloys as a finish, although it could be prohibitive in terms of cost. Then you also look at organic solderability preservatives. Okay. So, these are typically you are going to use some kind of a organic coating, okay, on the copper surface, and this coating, when it is cured or thermally cured, it could be a very good base for tin lead soldering. It would have good wetting, it could avoid corrosion. So, there are different manufacturers who offer OSP finishes. So, this is a surface finish that many people have been using over the last decade, and it needs a very good understanding of the type of material that is coated over copper. Now, let us look at components. So, if you are going to lead free soldering, what are the things that you have to take care of from the component side? Thermal stability of the component, because you are going to work at different temperatures compared to tin lead. So, consider component stability at soldering temperatures which are going to be high, especially if you are going to work with BGAs. The popcorning effect will always keep reminding us if we have not taken care of certain precautions like removing moisture from the BGA package before reflow soldering, and the behavior of these plastic packages at higher temperatures. You also need to look at the coating of the leaded components. Okay. If you are using QFPs, what kind of coating has been given on the iron nickel alloy, that is primarily the lead frame. So, a good understanding will help you in providing a very high reliability at the assembly stage with lead free. Consider component suitability at soldering temperatures, example electrolytic capacitors. Can they withstand these soldering temperatures? If not, can you move into some other capacitors? So, in one sense, you also look at passive components on their suitability for lead free soldering. Use ceramic packages, use materials that have a larger size. Okay. So, these are all design issues that you can look at. Alternative finishes from the component side, you can look at nickel palladium, may not be cost effective. Silver and silver palladium again may not be cost effective. So, look at tin copper, tin bismuth, tin silver from the component lead. For BGAs again it is a different ball game. you have to use BGAs that have lead free solder balls attached to its to the die. Now, from the solder side, it is very important that you are going to use fluxes, or flux could be a inbuilt component in your solder paste, right. When you use solder paste with screen printing or stencil printing, you are going to use flux. You are also aware of no clean fluxes, but generally there are different fluxes like mildly activated flux, low activated flux, and then super activated fluxes, and you need to understand what kind of flux is being used in that particular process. And as we saw a couple of lectures ago, the thermal profiling is based on these components. So, ensure flux compatibility with the alloy that is used. Use a resin or water based flux, so that the post cleaning process using aqueous based cleaning chemicals becomes compatible. Use no clean flux wherever possible. So, as you recall, when you say you are using no clean flux, the board after assembly need not be cleaned. That means there are residues that are minimal firstly. Secondly, if there are any residues, they are not going to affect the board. That is, even if the pads are close to each other or tracks are close to each other, the residues would not be harmful in terms of corrosion inducement or electromigration or any other shorting problem. Solder alternatives we have seen. The best thing is tin silver copper alloys for all techniques. Tin copper possible for wave operations, so you can consider that. Bismuth based solders for low temperature. So, this is a summary of the various situations that you can probably enter into for various designs and applications. Other alloys specific to the application, which we have seen during the last 4 or 5 slides, you can select, and you can use tin bismuth silver for reflow, provided the temperatures are suiting your process. Now, coming to the process side, if you are using lead free, have a look at the reflow profiles. Optimize your reflow profiles for the selected alloy. Do not work with earlier profiles that you have been using for lead based. Whenever you use a new material, change the reflow profile, do a trial run, and then optimize it, and then store that for all subsequent operations involving the same set of components, the same substrate, and the same solder paste material that you are using. So, optimize the reflow profiles, allow for narrower process windows, and here again the conditions should be based on the total time taken for a particular batch to be completed, and that again is related to the combination of the different types of packages that you have used, the solder paste material, and the equipment. For example, a reflow zone could be a 3 zone or a 4 zone reflow equipment. So, you have to work in tune with those conditions. The equipment, from the equipment side, try to maintain good temperature control, right, plus minus 1 degree centigrade. Consider energy consumption. Now, the residence time in each of the zones will come into question when you talk about this point. Okay, you have to save energy, because when you are moving into lead free compared to lead based, you are working at higher temperatures. Globally, there is larger energy consumption. This is a very big concern in the industry today, because sometimes you are working 40 degrees up from 183. So, if you look at global electronics industry, many people have commented about this larger energy consumption for PCB assembly. So, I keep repeating and saying that the thermal profile should be carefully considered to reduce energy consumption for assembly. Check temperature range of equipment. Okay. Sometimes because you are working with lead free, you would have been working with lead based solder, and now your equipment is incompatible for lead free. So, make sure your equipment is in place and consider using inert gas atmosphere, that is nitrogen based reflow. Now, this is an option that need not work for all designs. Okay. So, you can consider working inert gas atmosphere to reduce defects, but in some cases we have seen inert gas atmosphere in fact induces defects like tombstoning, skewing and so on. So, have a control on the conditions. So, the reliability of lead free solders or soldering process as a summary depends on material selection. The fatigue performance of tin silver copper solder is much better than tin lead, as we have seen over the years. Tin bismuth provides reliable joints for low temperature service, low temperature assembly. Lead free board finishes exhibit better solderability. There was a concern about the reliability issues, the wetting and the solderability, but now having seen the experience of many manufacturers and EMS services, lead free board finishes do exhibit better solderability. Fewer defects have been seen with lead free solder, or probably the process control has been well understood to reduce the defects. Reliability of tin silver copper in BGA ball grid arrays are greater than tin lead BGA based on thermal cycling. Okay. So, definitely we are moving in the right direction in using tin silver copper, one of the top preferences in the lead free zone, and we are replacing lead based very successfully by many companies and also by prototyping industries. So, finally, the benefits and concerns of all of these issues that we have been talking about is that there are environmental concerns that have been taken care of. Lead free solders are less toxic, reduced risk of lead entering and polluting the environment, compliance with forthcoming legislation of hazardous substances. Economically, costs may be very high if you are switching over to lead free. Converting to lead free assembly may involve other costs also, including training your personnel, getting into quality assessment, understanding the quality assessment in house, and certification of your employees and your company into the testing standards. For example, IPC is conducting various training programs. IPC is a global body, and maybe you have to train your engineers and certify your company, so that you will be accepted globally when you sell your product for lead free assembly, and your product could be certified successfully. Recycling and disposal costs may fall because you are using lead free, otherwise lead disposal is a problem. Profit margins may be higher for a green product, because you are now selling a green product, your tag is green, therefore, you may be having a leading edge currently in the global market, and therefore, you could in fact push a product with higher profits. Technically, improved reliability is possible if you are expert in understanding the processes. The board will exhibit better solderability and have a longer shelf life compared to lead. The only thing is you have to avoid pure tin, because we have seen problems with pure tin like whiskers and so on. Fewer defects with lead free solder than with tin lead solder in well designed processes. From the more economic and marketing angle, consumer willingness to support products with less environmental impact. So, people are also aware of environment and green electronics. So, there will always be a push for green electronics. Opportunity to demonstrate a company's commitment to the environment. Okay. So, these are very general comments. Now, we will move into so that completes the section on assembly including lead-free. We will now move into a few slides that concern green electronics. So, by now you are aware of the term green. So, in electronics, green electronics, the term is now a very key word to understanding a system or when you do a packaging of a product. What is the issue as far as electronics packaging is concerned? Let us look at some basics. If you look at the life cycle of an electronic product, okay, there are various issues that I have listed here, and if you look and relate it to the figure that I have shown here, there are electrical issues, mechanical and chemical issues when you design a particular product. So, it moves from design, supply components, raw materials, IC packaging, PWB fabrication, PWB assembly, then you have transport, user consumption, and then comes the important disposal or recycling. So, raw materials, production of IC and passive components, organic board fabrication involving a variety of chemicals. Okay. So, if you look at the life cycle of this product, these are some of the stages. Assembly of components using a variety of harmful materials such as lead, assembly of the resulting electronic product into end products such as systems like cell phones, laptops, camcorders, etc. Transportation of these products to the customers, usage and consumption of products, disposal and recycling of materials that could be harmful to the environment, which so far has been done in a view that has never been well clearly understood by the industry. Now, we are moving into a phase, an era where the entire scenario is redefined. At each stage, we are looking at what are the harmful entities that go into a product, how to remove them, how to replace them with newer materials that are safe, and finally, looking at end disposal and recycling issues. So, let us carefully look at the various entities in each of the stages of a product design and product formation. If you look at the first stage, wafer and IC fabrication, there are pretty much too many solvents used, too many chemicals used. Potential solution is that try to replace them with non-harmful solvents and chemicals. IC packaging and assembly, lead that is used in solder, cleaning flux, there are chemicals that could be harmful to the environment. So, replace it with lead-free solder, use conductive adhesive attachment, okay, instead of using solder material, you can use conductive adhesive as we have seen in flip chip bonding and so on. Okay. Minimize solder usage, that is the way to reduce the risk of such elements. At the system level, printed wiring board and assembly, again you are doing soldering, lead based solder, cleaning flux in assembly. I mentioned before bromine used as a flame retardant in PCB, solvent emission in PCB manufacturing process during substrate cleaning and so on. So, these are potentially risk areas for the technician, for the environment, it is a health hazard. So, solutions: use lead-free solder, use conductive adhesive again for SMD components and fine pitch components, use non-halogenated flame retardant materials like those that contain phosphorus instead of bromine, use a solvent free PWB process, move into more aqueous based cleaning or aqueous based chemistry. System assembly, if you look at batteries used in system products, cadmium is an issue because that is to be eliminated. Then halogen flame retardant in housing and so on. So, use alternate battery, use non-halogenated flame retardant. So, what are the risk substances used in manufacturing process, but not in the final product? Solvent is a big concern used in PCB manufacturing. So, chemicals used for flux cleaning during soldering process, then chemicals used in the etching process. Okay. Those materials like chromium, for example, which were earlier used in the etching process in the PCB fabrication needs to be eliminated, okay, because again hexavalent chromium is banned, but handling chromium, which is very corrosive and harmful to the personnel working, needs careful consideration, because there are a lot of alternatives available to such chemicals. Now, how do you treat wastewater? Because there are various processes in the IC manufacturing and the PCB manufacturing, which involves a lot of deionized water which gets contaminated during the process cycle, and the volumes are very large and it cannot be just like that sent into the municipal drain. So, you need to look at how water can be treated and recycled. Volatile organic compounds used in flux and solder paste require very careful consideration. The effects of these risk substances will lead to the following concerns. We have seen that basically the first thing is the health hazard to the personnel directly exposed to the risk substances. Global warming, I do not have to be too vocal about it. Most of you are aware of this issue. Bad odor and poor working environment in the industry or the workplace, destruction of ozone layer in the stratosphere, acidification of rain by generation of photochemical oxidants, and contamination of landfills is a major issue. When these electronic substances are being thrown in the landfill as a landfill, then this is going to penetrate into the earth, and then the effects are going to be seen much later. More energy to be spent to recycle risk substances can be avoided, okay, because if you are using materials that are easy to recycle, cost effective from the spent e-waste, then you can have savings. As an industry, from that point of view, it is going to be very important. So, better energy utilization in electronic products is also an important aspect of green electronics design and manufacture. Now, I will conclude with a few slides by showing you some terms, some kind of a symbol or logo that all of us will have to be aware of when you buy an electronic product or use an electronic product, or if you are in the industry, if you are producing a product, then you have to certify yourself or your product based on global legislation. The first thing is the WEEE logo that you see on the top right corner of this slide. This is the logo of the WEEE organization or council, which stands for waste, electrical and electronic equipment, electronic waste, e-waste, e-scrap or waste electrical and electronic equipment. This logo defines that or describes loosely discarded, surplus, obsolete, broken electrical or electronic device. So, it is a waste from an electronic product which needs attention, which needs to go for recycling, careful recycling, considered recycling. It cannot just be thrown into the dustbin. Then the other term that you will see in most products, which is RoHS, that is restriction of hazardous substances. Now, the logos that you see on this slide are not official logos of any organization or anything. If you are producing a product, you have to give a RoHS logo that you can decide, and these are just simple examples that have been taken from the literature. Now, basically you have to comply with the global legislation, and you have to certify that your product is RoHS tested. Now, what are the materials that are coming under this list? Lead, cadmium, mercury, chromium, which is hexavalent, and brominated flame retardants, that is used in FR4 laminates. So, these are the 6 materials, including diphenyls and diphenyl ethers and so on. So, under the broad category. So, these are the basic chemicals that are being considered or being written as listed materials, materials that come under the legislation of RoHS. Unorganized recycling and disposal of e-waste involves significant risk for lives of workers and communities. For example, people who are involved in recycling these electronic product components. Great care must be taken to avoid unsafe exposure in recycling operations and leaching of materials such as heavy metals from landfills and incinerator ashes. So, when these are keyboards, monitors, printed circuit boards from computers, desktops are being thrown in landfills, people try to recover these components or separate materials including batteries and so on, and these pose a lot of health risk for the workers. So, this is unorganized recycling sector which should be discouraged. So, normally what one needs to do is pass on the e-waste to a licensed recycler that could be identified in your area and that is approved by the government as a authorized recycling agency to take care of your e-waste, because they have the right procedures, the right methodologies and the right working environment for their employees to recycle the waste. So, there are many questions. If you look at this slide here, there are many questions that could be asked. Now, these are questions that I have put for us to answer ourselves and see how do we understand this humongous problem, the larger problem of green electronics. So, what is RoHS, you know, what is WEEE, you know, what are the restricted materials mandated under RoHS, you know now. Why is RoHS compliance important? Only then you can be at the leading edge of manufacturing. How are the products tested? Because you know the various materials, you eliminated them from your production line and then you can easily test for compliance. Which companies are affected? It could be PCB manufacturing, it could be PCB assembly, right. So, why is there a push for lead free solders in electronic soldering applications? Because only then you can get a safer product, because we are looking for the next generation of people to live in a community that is devoid of these hazardous substances. Now, why should some lead free alloys be approached cautiously? I am putting these questions because we have seen these topics already. Okay. Now, the reason why we should approach lead free alloys cautiously is that we are going to work at higher temperatures. Therefore, look at process, look at components, look at your substrate and judiciously take your lead free choice. Are lead free alloys as durable as tin lead? Yes, we have seen some of those issues. How do lead free alloys compare to tin lead alloys for application, high temperature application requirements? Experience has shown, literature has shown that lead free alloys are as comparable to tin lead in terms of reliability and sustenance in various temperature environments. Now, can they work with different flux types? Yes, only thing you need to know the temperature range and the activation in the reflux thermal profile, reflux soldering thermal profile. In what solder forms can lead free alloys be produced? They are available as solder balls, pellets, wires, as bars. Okay. So, in all formats lead free alloys are available, you can choose them as required. So, what are the attributes that one should look for while searching for a lead free alloy? So, basically what you need to look at: low cost, easily repairable joint, compatibility with existing parts, packages and processes, and no toxic or exotic constituents which could be cost prohibitive. So, this is a summary of the RoHS. Have a look at these slides which I have taken from ewasteguide.info, just to basically show you that the landfills are totally filled with electronic products at the time when there is no organized sector for this. Today it is a new story. Things are looking organized in this sector because of various organizations, including private NGOs and so on, and government especially taking more efforts in bringing an organized activity as far as e-waste recycling is concerned. And to top of all of this, in India, our country, we have finally a law versus with the e-waste material. Okay. So, the government of India has brought a new regulation, and it has given certain procedural steps for manufacturers in the electronic sector as to how they should handle e-waste. The same goes with various organizations. If you are producing e-waste, you have to have certain procedures laid down to hand over the e-waste to an authorized recycling agency, and we are now looking at many companies coming and applying for licensing to start up organized e-waste recycling. So, this will be effective 2012 May 1st, and then you will see that the e-waste will be very properly handled, okay, by an organized sector. So, this concludes the chapter, that is module 7 on surface mount assembly, advanced packages assembly, issues with materials, soldering materials, joining processes, soldering processes. We have also seen lead free alternatives, and we have also looked into very important aspects of green electronics and what you as an individual or as an employee in industry or a management in an industry in the electronic sector need to look at as far as e-waste is concerned. Now, we will conclude this module by looking at some questions and answers that will help you finally understand this module very effectively. So, we will spend about 7 to 8 minutes on this tutorial, and you can also get back to me on any issues or clarifications regarding this tutorial. More questions in the form of a questionnaire or a quiz will be posted in this particular course website. Now, if you look at the first question, some SMD resistors have a case form of 0402. What are the dimensions of this resistor? So, we have seen that 0402 means it is 0.04 inches by 0.02 inches. Okay. So, this is the dimension of the resistor. What is the melting point of 6337 tin lead solder material? All of you are aware of this. It is 183 degrees centigrade, and this helps the attachment of various components with the printed circuit board, even if it is a low TG printed circuit board. List the different methods of machine soldering. You have seen the different methods. One is reflow, the other is wave soldering. The other machine soldering process that you can think about is laser soldering, although this is used in very small volumes. So, what is flux? What are the functions of flux during soldering? There is a separate lecture we have dealt with on this. So, flux is very essential, because firstly you need to look at wetting, you need to look at solderability issue, reducing the contact angle, contact angle of the joint, and providing a good joint, then producing a corrosion free deposit, that is, you have to remove the oxides from the board. So, these are some of the various points that you can write for this. Why are adhesives printed on printed wiring boards before SMD mounting? Because in the case of very small components, lightweight components, and if you want to do a double sided reflow to provide a very good gluing or attachment to the board, so that the components do not fall. So, especially useful for double sided wave soldering process, requires gluing with adhesives. So, what is the function performed during IR or thermal resoldering? So, basically here if you are using a solder paste, the solder paste will melt, the board gets activated, the solder pad on the board also gets activated, then the component leads, the coating on that also gets activated. So, at the melting point the solder paste will flow and fuse with the component lead and the pad on the PCB to form a very good joint. Can SMDs be repaired on board? Yes, you can repair, provided you have the right tools. As you have seen in SMD, there are different sizes, the pitch could be very small. Now, in QFP again, if you are going to 0.3 mm QFP repair and rework, then you should have special tools for this. Most stencils are preferred to seal screens during screen printing process in SMT, because in metal you can provide very good imaging and very good dispensing of the paste in the right volumes, right. So, and that is highly reliable, and you could have a very good 1:1 photo tool to PCB translation of the pad size. Pad size means pad volume dispensed in the right areas. RMA in flux type stand for what? RMA stands for Rosin mildly activated flux. Okay. So, can have other types of fluxes also, as you can see in the lecture, earlier lectures. So, 2 to 3% of silver is usually added to tin lead solders. Why? We have seen this in tin lead silver chemistry, and we have seen that 2 to 3% silver aids in wetting and also providing a good finish, a good appearance, and also the strength, increasing the solder joint strength. So, you can give these reasons for that question. What is the function of preheating in machine soldering process when using Rosin fluxes? Is it to activate the flux? So, basically in machine soldering process, you have to preheat to activate the board first, and also remove the solvents and activate the flux, because if it is a mildly activated flux or low activated flux, you require more time. So, flux activation is very important. What is dross? How do you dispose it? During wave soldering, the tin lead molten solder is exposed to air. So, that reacts with air to form oxides. So, this oxide is known as dross. Now, this could be an impediment during the wave soldering process. So, very regularly you have to remove this dross, and then you have to dispose it carefully because it contains lead, and then carefully send it back to the recycler to recycle the metals. Give 2 reasons for tombstoning and skewing in SMD assembly. As we have seen, if you are working in nitrogen atmosphere in a reflow process, the different copper pads of let us say SMD chip component could get different volumes dispensed, or it could be different temperatures on the copper pad, or the time taken for reflow could be slightly different between the two pads. That makes the force exhibited on one terminal of the chip component to pull the entire component to its side, leaving the other pad open. So, this is tombstoning. Please refer to the library, SMT failure library that we have discussed. Similarly, there are other questions that I have listed here in this particular PDF. This PDF is available along with this chapter in this particular course. So, take your time to go through these remaining questions, and then you can get back to me for more detailed answers.